explore the potential nonlinear relationship between the number of coffee shots and flavor intensity. Flavor intensity in coffee is a multifaceted attribute shaped by the type of beans, roast level, and brewing method. The number of coffee shots also plays a crucial role. The graph here illustrates how different roast levels, light, medium, and dark, affect flavor intensity across varying numbers of coffee shots. On the x-axis, we have the number of coffee shots ranging from 1 to 5, and the y-axis represents flavor intensity on a scale of 1 to 10. Notice how each roast level, indicated by different colors, shows a distinct pattern in intensity. While light roasts start with lower intensity, dark roasts reach higher levels more rapidly. This variation suggests that the relationship might not be strictly linear, setting the stage for our deeper exploration into this intriguing aspect of coffee flavor. To investigate whether the relationship between the number of coffee shots and flavor intensity is nonlinear, we begin by differentiating linear from nonlinear connections. In a linear relationship, seen in the blue line on the graph, the change in flavor intensity is proportional to the change in the number of coffee shots. Notice the steady, predictable climb. Conversely, the actual relationship, shown by the orange line, is nonlinear, lacking this proportionality. As the number of coffee shots increases, flavor intensity rises, but the increment is not consistent, often leveling off. Understanding both these dynamics helps us explore their implications for coffee flavor, particularly how adding shots affects taste unpredictably. Moving forward, several factors fundamentally influence coffee flavor intensity. High-quality coffee beans are foundational as their origin and treatment directly affect flavor nuances. Grind size is another critical aspect. Finer grinds typically lead to stronger flavors due to a higher surface area for extraction. Water temperature also plays a pivotal role. It determines how well flavors are extracted, with too hot or too cold water potentially missing the desired balance. Additionally, extraction time is crucial. Over-extraction can lead to bitterness, while under-extraction might result in a weak taste. The brewing method significantly alters perceived flavor, as shown in the graph comparing espresso and drip methods. On the x-axis, you'll see the number of coffee shots, while the y-axis represents flavor intensity. Notice how both methods depict increasing intensity with more shots, but each exhibits a unique curve, further illustrating the complex interplay of these factors in determining flavor. The graph displays the nonlinear relationship between the number of coffee shots and perceived flavor intensity. As indicated along the x-axis, which represents the number of coffee shots, and the y-axis, showing flavor intensity, the curve demonstrates an initial increase in intensity with the first few shots. However, as more shots are added, the incremental increase in intensity diminishes, suggesting a threshold of diminishing returns. This illustrates that flavor intensity doesn't rise consistently with each additional shot. Another factor contributing to this is palate fatigue, where the ability to perceive intensity decreases over time, affecting how we experience subsequent shots. The nonlinear pattern seen here highlights these complexities in understanding coffee flavor perception. By understanding the nonlinear relationship between coffee shots and flavor intensity, coffee drinkers can optimize their brewing for the best taste experience. The graph here shows that while we might expect a steady increase in intensity with more shots, the actual flavor intensity, depicted by the solid blue curve, rises initially but then levels off. This means simply adding more shots won't continually boost intensity, as one might assume from the dashed orange line, which represents the expected linear increase. For both baristas and coffee enthusiasts, this insight is crucial. It helps in achieving a balanced flavor, guiding decisions on the perfect number of shots to use for an ideal cup of coffee. Summarizing our exploration, the relationship between coffee shots and flavor intensity appears to be nonlinear, with diminishing returns affecting flavor perception. Sensory adaptation plays a critical role here, where the ability to perceive flavor intensity lessens with successive shots. This means more coffee shots don't necessarily increase intensity proportionally. Optimizing the flavor involves finding the sweet spot where the number of shots maximizes enjoyment without excess. This approach enhances both the coffee experience and resource efficiency, ensuring that the resources are used optimally for the best possible flavor.